In this tutorial, we will learn how to implement audio files playback in a web page using WebAudioXML, and we will also learn how to trigger them with buttons and stop the sound, and also to mix between the two sounds using a slider. Okay, so this is the result. We have a web page with two sound files. I call them A and B, and we can start them. And we can mix between them. And we can stop it. And this is how it works. There is an audio.xml file where we implement the audio files using the audio buffer source node element. And here's the place where we specify the source for the file, and also if you want loop to be true. I also added a class to this element, and this is to connect it with the buttons. So in HTML I can make a button and use the attribute data WAXML. It's a short for WebAudioXML, so I call it WAXML or something like that. Click and start. So this will ask WebAudioXML to attach an event listener to the click event on that button and make a call to start something in WebAudioXML. So what will start? That will look for any elements in WebAudioXML having class set to loop. And if you are familiar with CSS selectors, this is like standard for you. So it's .loop means that any element with class equal loop in the structure will listen to this call. You can use IDs with hashtags and everything exactly as you do in CSS. So because these two have class set to loop, they will both start playback when we hit that button. And it's good to know that it's not a perfect loop. It's an MP3 file in this case, and it will start playing back the first sample after it has played the last one. So it's not a perfect musical loop. And if you are interested in that, you need to look into my library iMusic.xml, which is dealing with those things. But for now, let's just be happy with the audio playing back, and let's focus on the volume between and the mixing between the two different sounds. So I think we start in the XMLs on the XML side. I have an input element here, which is the slider. And I set it up to be a type equals range, which is the slider type, and then a minimum and a maximum value. I just chose 0 and 100 here because I think it's convenient for a slider if you want to see the numbers and understand what you're doing. But it could be any number, and I will tell you how to connect it to make sense in audio soon. I also type value equals 0, which means that it will start all the way to the left hand side when it starts. And finally I use the WebAudioXML attribute called data WAXML target equals, and then I type $mix here, which is a variable name that I just came up with. So I established the variable $mix here. That means that the HTML side is kind of calling WebAudioXML, setting a variable called mix to the current value when you move the slider. But then for that to be used, we need to pick up the value in the audio configuration, and this is how we do it. Anywhere where you can use a number to set something, that could be a gain or a frequency or anything, but in this case the gain, we can use the same name for the variable. So in this case $mix. So that will now represent the value currently set with the slider in HTML. And by adding some simple math to it, we can calculate a sensible value between 0 and 1, where 0 is quiet and 1 is full volume here. So if I set gain equals 1 minus $mix divided by 100, that means that when the slider is all the way to the left, that means 0, it will say 1 minus 0. and the result is 1, of course. That means that this sound will play with its full volume when the slider is set to the left. When the slider is set all the way to the right, it will have the value of 100. So the math then will be 100 divided by 100, that is 1. So then we have 1 minus 1, which is 0. So the first sound would then be all quiet when the slider is all the way to the right. And the opposite is true for the other sound. So the math here is mix divided by 100, which means that if the slider is 0, well, then the volume is 0. And if it's 100, it would be 100 divided by 100, which is 1, and then full volume. So that is how we link a slider to set the value in WebAudioXML. We can make it a bit more flexible and also complicated if you would like to. And I added some comments here about what we can do. So I will take away these classes from the 2 first sound objects and move it down here to the complex setup. So now we listen to these objects, which is they're using the same file, so it sounds the same. The new thing though is that we store the variable in a temporary kind of memory on the way to control the volume for these sound files, and this is how I do it. So I established another element here called var, which is a variable. I give it a name, in this case mix_a, and I prefer to use only lowercase characters and rather using underscores than going for capitals. And that is to be able to control them from HTML, where we can't use capital letters in the attributes. So that's why I'm using the underscore and a smaller case a here. So this variable will have the value set by this variable, the $mix, which is the value controlled by the slider. So, well, it will actually mirror that value. But there is an important difference. And that is that we can have map in and map out specified. And in this case, it's super simple. So I map the value from 1 to 100 to an out value from 1 to 0. So that means that when the slider is 0, we will have the value of 1, which is maximum volume for that mix A. And when the slider is 100, it will map to 0. And then we will interpolate between those two values. And the cool thing is that we can have any number of values here. So we can have, well, a curve that is responding to the input in an interesting way, if we would like to. We could also do interesting mappings, and I write more about it on this web page. But for example, we can convert MIDI note numbers to frequencies. We can convert decibels to power values. And we can also do different curves, like we do with CSS animations. So we can do ease in and out and stuff. So if you're familiar with crossfade, equal power or equal gain, this is the place where you can use the curve attribute to specify how the values should interpolate between the lowest and the highest. And I think what I've written here is making the first value easing in towards the target. That means that the I don't know about left and right for you now, but this is my left. So when we go from top maximum volume to lower volume, it will ease in towards the 0. Whilst the other sound, we need to ease out from 0 towards, no, sorry, this is so confusing. So, yeah, the first one is actually easing out from number 1 and then falling quickly towards 0. And the other one is easing in towards the maximum volume. Was that correct? No, this is easing in. So that means that we have equal power rather than equal gain. And this is useful when we have different sound sources and we would like to mix the crossfade, not to drop in volume in the middle region. It's a bit complicated, but there are lots of web pages describing this phenomenon, which is typical for crossfading. Anyway, so now we've established those two variables, and that means that we can use them later in the code. So now the mixer for this sound is reading the $ mix A, which looks for a variable object with the same name, and it finds this one and it will work. So now save it and go back to the demo, reload, and start and listen. And you might have been able to hear that the drums are kind of coming more quickly than they did before. And if we do the opposite, so if we do 0.5 for the first variable and 2 for the other one, we will rather have a drop in the power in the middle, like this. So it takes more time for the drums to enter. We lose the pad as well, dropping in volume in the middle, and then drums are raising more quickly at the end towards maximum volume. So, well, anyway, this is super complex, and you can do all sorts of interesting things using those numbers. But please read more on the link, and I hope you understand the potential in this way of coding audio. Good luck!